Hello, Tom here from Every Step Calculus, everystepphysics.com. I'm going to show you how to do this problem here of x cubed times the square root of 1 minus x squared. We're going to integrate it using trig substitution. These are all right triangle baloney stuff, waste of time, puzzles, as usual with calculus, solves nothing useful. And this is a proper, really a good example of it, you know. Now there's three systems, of course. You're doing, substituting tangent, substituting secant, substituting sine in this case, okay? And there's a system, so I've done all three of those, or four of them, for you to enjoy doing your homework. This won't appear on a test because it's too hard. This takes maybe a page and a half to do it on paper, and you come up with something more complicated than even this. And yet remember that an integral is an area under a curve, and so if you was to because it's got an x cubed, if you were to graph that, you could see it. Try it, you know. I want to put square root sqrt in here because that's what the students put in Google when they search for a problem, and there's not many that comes up with this problem because it's pretty difficult. And then even more difficult when you put a 4 here for this instead of the 1, or a 9, or something squared, you know. How does that happen in real life, right? So you're always dealing with the adjacent side, the opposite side, and the hypotenuse of a right triangle in these problems. And you'll see how hard they are when I do it here, and what a waste of time it is. But you need to do your homework and put something on your homework and pass you this course. So that's the reason I tell you to buy my programs and for $40 and enjoy passing calculus with all this baloney, okay? Otherwise study it yourself, fine, be my guest. Alright, but let's do it here. Index 8, I'm already at integration by parts, and I'm going to enter the function. We're going to press, I've already entered here, so I'm not going to waste time putting this in, but you'd press alpha and then put x cubed times the square root, use the square root sign, which is second x here, and then the 1 minus x squared, and close off the parentheses, okay? I've already done that to save time, make sure the simulator doesn't screw up on me. And I say it's okay. I give you a chance to change these problems every time, but you have to press alpha to put any characters in my problems, okay? And when it's busy here, it's loading the program. And we're going to use trig substitution, okay? And here's the rule here. A squared minus v squared. That you're substituting x equals a times sine of theta. Now in this case, a is 1 squared, so 1 is for a, so you don't use it, you know. But if that was a 4, then you'd use 2 here, etc. And then v squared is the x squared part, okay? So this is the rule here, which we're going to use in this situation. And I show you that v is equal to square root of x squared equals x, and a is equal to the square root of 1 squared, which is 1, okay? So x is equal to 1 times sine of theta, and dx is equal to 1 times cosine of theta d theta. Now generally the function is x cubed times the square root of 1 minus x squared, so then I have I equals the integral of x cubed times the square root of 1 minus x squared dx. So we're going to substitute this, the sign. We're going to start. So we have the integral here, and we're going to substitute sine of theta for every x up here, okay? We do that. Now I'm not going to talk you through each one of these things because I'm not interested in teaching you how to do this problem. This shows you how to do the problem, and you don't sit there and study it, and you just write whatever you see on this screen on your test sheet or homework, and then study something more important. And there's identities involved, you know, of course. Cosine of square root of theta is equal to 1 minus sine squared of theta, and we substitute that in there. Cosine squared of theta, and then we use algebra. Square root of something squared is is cosine of theta, okay? That becomes cosine squared of theta. Now we split this out, sine times sine squared of theta, so we can add another identity, which I've done here, see? So now sine squared of theta is an identity, so we're going to add that in there, the 1 minus cosine squared of theta. Here it is. Now we're going to multiply sine of theta, cosine squared of theta, using algebra, times 1 minus cosine here of squared, okay? We're going to separate, and we're going to multiply it out and separate the integrals, because you can never integrate when something has a times. You have to use U-Substitution or integration by parts or something of that sort. As soon as you see a minus sign, now you can integrate. If it's separated by minus or plus, you can integrate, but not if there's a times or a division sign, okay? You have to use other systems. So here we've multiplied it out, integral of sine of theta times cosine squared of theta d theta, and then we're going to, and then minus the integral of sine and cosine 4 to the 4th power of theta, okay? That's all. Just, you can do that, can't you, in algebra? Sure, anybody can. And we're going to integrate the first integral here, okay? Now we here, because we have a times and we have to use U-Substitution, okay? So u equals cosine of theta du, d theta equals, we're just kind of using algebra to switch that around, d theta is equal to du divided by minus sine of theta, right? And so we do these substitutions and we come up with the, what we're integrating here in respect to u, and this turns out to be u cubed divided by 3 plus c. So now we substitute cosine cubed divided by 3 plus c. That's what the thing works out to be. And we integrate the second integral the same way, and that turns out to be minus u5 to the 5th power. We combine the answers here, minus cosine cubed theta divided by 3 minus a minus cosine, that's a trick there, minus cosine to the 5th divided by 5. And we do the computations, and then that, this minus here turns into a plus. You can see that, right? So now we're going to switch it back here. X equals sine of theta, so because of our knowledge of trigonometry, sine of theta is equal to the opposite side over the hypotenuse, okay? And now I even show you the triangle here. Here's the hypotenuse with 1, and here's the opposite side with x. Here's theta here for the angle, right? And here's b for the adjacent side. So we're going to find the adjacent side. A squared plus b squared equals c squared, right? X squared equals b plus b squared equals 1 squared, right? C squared was the hypotenuse, and that was 1, so that's 1 squared. B squared equals 1 squared minus x squared. B equals 1 squared minus x squared, which is really 1, of course. 1 minus x squared. Now the cosine of theta is equal to the adjacent over the hypotenuse, so you got the, what we found out was the adjacent side over the hypotenuse of 1. So minus cosine cubed of theta divided by 3 plus cosine theta to the 5th power divided by 5 plus c. So the answer, and we substitute back the x's, here's the answer here, okay? Pretty easy, huh? You could have done that in a second, couldn't you? Well, anyways, go to my site, buy my programs, and enjoy passing calculus if you want to pass it. Otherwise, suffer like I did. That's the reason I designed these programs. I couldn't pass it. I had to have my programs. So anyways, have a good one. Good luck in your classes.